Hello, this is Mrs. Davis. I am teaching calculus, AP Calculus Lesson 8.2, connecting position, velocity, acceleration with integrals. This is the first video, and let's just go into a overview, which is, I think this is an excellent breakdown of what you need to know. So this is an excellent overview. So let's look at what we have here. And I'll just be highlighting, so highlight as you go too. So on the AP exam, 3 possible prompts with motion involving definite integrals are displacement. So it's like, what is the particle's displacement between, or what's the change in the particle's position? That's displacement. Total distance. What is the total distance the particles traveled? A lot of times, guys, this will just say the distance. And you're supposed to assume that it means total distance. So be careful. Try to figure out for sure whether they're talking about displacement or distance. And then the third one is about, hey, where is it right now? What's the actual position? Okay, so let's look at these 3 and how you work with them. So if you want displacement, you start with the integral from a to b of the velocity, dt. So this means it's just, sorry, got to get back here. This is just accumulation. Okay, what did I do from here to here? That would be the displacement. So it doesn't matter whether I went forward or backwards or up or down or whatever. This integral will figure that out for me, and it will subtract. So it's saying if I started here and went backwards, this is the displacement right here. So you're getting this distance, okay, using the integral. So that's accumulation. Now, the total distance looks very similar, except it's the absolute value. And that's because we have to include this distance and then the negative distance also. And so we have absolute value over the velocity. And the third one, the actual position, where is it now, has to take into account need the starting point. Okay. Oh, okay, or the initial condition. So, if they give you, hey, at time 0, I was at 5, you're going to have to use 5 here, right? Or, f of 0 or whatever, so that you start where you're supposed to. And you're accumulating after the fact, and here's the accumulation after where they told you to start with. Okay, so remember those 3 things. This is the absolute value. Okay, now we have here a chart which goes through everything you have to know. It's a summary. And so I am going to try to go through this, and let's see if I can get a highlight color that's not too bothersome. I guess I'll just use, let's use pink. Maybe that's okay. So all of these I'm just going to go through really quickly. Initial position. Okay, so if you start at the initial position, or you could start with velocity or acceleration, then it's at t equals 0. So if they say initial, it means t equals 0. If it's position, it's s of 0, a of 0, or v of 0, right? So time is 0 in that case. So that's what initial position means. Particle is at position s, means that it was at a specific time, it was at a specific place. So that's self-explanatory. The particle is at rest, means that velocity is 0. So you set v of t equal to 0. Particles moving to the right, that means the velocity is greater than 0, and to the left it's less than 0. This some repeat from when we did velocity acceleration with derivatives. Average velocity, so it's the average velocity of the particle. Okay, now look, there's 2 different things here. If you're given velocity and they ask you for the average velocity, then it's the average value, which is this. If they give you the position function, not the velocity function, you have to do the average rate of change. That's all you can do. Okay, because you were just given the position. All right, so going back, instantaneous velocity is the derivative of the particle. So instantaneous velocity is v of t is s prime of t. Acceleration of the particle at time t is a of t is v prime of t, which is the double second derivative. All right, so those are, to go back and forth between s of t, v of t, and a of t, and I think you know that. The velocity of the particle is increasing. Okay, if that's true, that means a of t is greater than 0, because this is the rate of the rate. So we have the velocity, which is a rate, and it's increasing. So what's the rate of change of velocity? It's acceleration. Okay, so acceleration has to be greater than 0, or the derivative, v prime of t, has to be greater than 0. The speed of the, velocity of the particle is decreasing. That means that a of t is less than 0, or the derivative of the velocity is less than 0. Again, you're talking about a rate decreasing, so again, that has to do with acceleration, or v prime of t, Now, the speed of the particle is the absolute value of the velocity. You've already learned that. The speed is increasing, or the particle is speeding up. The speed of the particle is increasing, or this particle is speeding up. Now, this is the one where you have this little rule that means if the velocity and the acceleration have the same sign, they're either both greater than 0 or both less than 0, then you have it speeding up. Okay, or the derivative of the absolute value of the velocity is greater than 0, which is the same thing, but we usually don't do with that. Speed of the particles decreasing means that the velocity and acceleration have different signs. One would have to be greater than 0, and one would have to be less than 0. Now look, there's the speed of the particle, okay? That's just the absolute value of the velocity, and then because that's just velocity, right? Then they're asking, is the speed increasing or is decreasing? And so that's a rate of a rate, okay? Speed is a rate, but is the speed increasing would be rate of a rate. So don't get those confused. They both have the word speed in them, so you have to read through them. So this is important. The total distance traveled by the particle over the time, we just went over that, and the little above thing, that's the absolute value of the velocity. The displacement is just without the absolute value, just the integral of v of t. Position of the particle, okay, here's the big one. Position has to include your initial position. So s of t, and then t of 1 to t of 2, and now remember, those two have to be the same thing. And then particle changes direction. That's where the velocity changes from positive to negative, or negative to positive. So there's your justification. And the particle is furthest to the left. That means you have to find the minimum or maximum value of s of t. So how do you find the minimum value? You would take the derivative, set it, which is the velocity, set it equal to 0 to find the critical points. And then you're going to have to use a candidate test, because it could be the endpoints also. All right, so that was summary of all you need to know in Calculus 1, including derivatives and integrals for particle motion. All right, so I'm going to stop this video here.